Okay, so for the next three videos, we're going to be looking at proofs. So there's three different types of proofs you need to know in Pure 1. There's proof by deduction, proof by counterexample, and proof by exhaustion. So we're going to go through each individual proof in each separate video. So the first thing is going to be proof by deduction. So what this means is we just have to follow a series of steps, logical steps, to prove that it's correct. Okay, so making sure that these steps are logical and they are correct. As long as they are correct, then we can prove that something's wrong or right. So there's a number of different types of proofs that they might ask you. So we're just going to go through some of these quickly. So for example, question 1. Prove that n squared minus n is an even number for all values of n. Right, so for this type of proof, what we have to do is say let n equal to 2k and let n equal to 2k plus 1, okay? Where k is any real number. Okay? This just means that if k is any real number, it could be like 1, 2, 3, 4, 5, right? And so that means n is going to be 2, 4, 6, 8, i.e. all the even numbers. And if you put it into the second case, 2k plus 1 is going to be 3, 5, and so on and so on, so all the odd numbers. So you're just trying to prove it's correct for even numbers and the odd numbers separately. Right, so it's n squared minus n. So if it's n is 2k, then we go 2k squared minus 2k, 2k all squared minus 2k, which is 4k squared minus 2k, which I want to prove that it's even, right? So if it's even, 2 is a factor, right? So I can take 2 out and say it's 2k squared minus k. So it just proves that for all k values, where n is 2k, is going to be a factor of 2 or an even number. We do the same thing for 2k plus 1. So 2k plus 1 squared minus 2k plus 1 in brackets. Expanding this, we get 4k squared plus 4k plus 1 minus 2k minus 1, which will cancel out to 4k squared plus 2k again, which is 2 times 2k squared plus k. So once again, because we get a factor of 2 outside, we've proven that it is an even number. For an odd number, what you should get is like this, but plus 1 like here, because that way an even number plus 1 is always going to be an odd number. So if they ask that n squared minus n is an odd number, then this is how you'd go about proving it. Right. The rest of these the questions are maybe like 2 to 8. It's just a matter of expanding the brackets. We've learned about expanding brackets and simplifying. Okay, so this part is not too difficult as long as you follow those steps clearly and you expand the brackets properly. And questions 9 and 10 is also important because it tells us whether it's a positive or negative number. So let's look at this question 10. It says, use completing the square to prove that minus n squared minus 2n minus 3 is a negative number for all values of n. So minus n squared minus 2n minus 3. And they said complete the square. So I can take minus out, n squared plus 2n minus 3. And complete the square, so this is going to be n plus 1 squared minus 1 squared minus 3, which will give me n plus 1 squared minus 1 plus 1 minus 3. So minus 1, sorry. So this will be minus n plus 1 squared plus 1 minus 3 is minus 2. So we've proven that this is all going to be a negative number. The way we prove it is, well, n plus 1 squared, if it's squaring any value, right, even if it's squaring a negative number, it always becomes positive, right? So this is always going to be a positive value, i.e. bigger than 0. But therefore, minus n plus 1 squared is always going to be negative. And then because minus 2 means you're subtracting again, therefore minus n plus 1 squared minus 2 is always going to be a negative number. This is how you go about proving that it's all negative numbers. Some other types of proofs I might give you is to do with shapes or like triangles or parallelograms, stuff like this. So for example, triangles, they might ask you, oh, is it a right angle triangle, or is it an isosceles triangle, or an equilateral triangle? In each case, you just have to look at the lengths of each side. So finding the distance between two coordinates, which we did in the previous video when dealing with lengths, right? So in this case, in 14, they said, prove that A, B, C are the vertices of a right angle triangle. In this case, right angle means that it's 90 degrees, right? So we're going to be looking at the gradients between A and B and C and making sure that they follow the perpendicular gradient example. Stuff like parallelogram here, we once again look at the gradient because a parallelogram has two sides which have the same slope, right? So there'll be two lines which have the same gradient, and the other two lines will also have the same gradient. And as I said, it goes for most of these are just basically just looking at the shapes, looking at the gradients of the lines and the lengths of the lines. The only other difficult one may be 19, where you can say that prove that this line is a tangent to the circle We know tangent is when it crosses once, right? So to prove that it only crosses once, we can use the discriminant, right? Because that way we know that the root, or there's a repeated root, so b squared minus 4ac will be equal to 0. So this is probably a more difficult one. Maybe you guys can try this one here and just prove that it is a tangent to the line. But proof by deduction is not too difficult. As long as you just follow your logical steps clearly and then get to the final answer, then it's pretty much that's all you really have to do for this type of proof.